All right, welcome back everyone to Inclusive Design 24, brought to you in partnership with Barclays Access, the Paciello Group, Utopia, Microsoft Edge, and Open Access Technologies. Don't forget you can subscribe to Inclusive Design 24 on YouTube by visiting youtube.com/inclusivedesign24 and hitting the subscribe button. Don't forget to follow ID24Conf on Twitter. And if you have questions for the presenters, tweet them using the ID24 hashtag, and we'll ask them at the end of the session.
And on that note, we're delighted to welcome Jared Smith from WebAIM back to Inclusive Design 24. And this time, Jared's giving a talk I'm really looking forward to on peeling back the layers of accessibility. Jared, over to you.
Thank you, Leonie and Scott, and thank you to all of the sponsors, everyone from the Paciello Group, Barclays, everyone that makes this wonderful event happen. I'm just thrilled to be a part of it. And I just want to dive right in to my presentation on peeling back the layers of web accessibility. I'm Jared Smith from WebAIM. WebAIM is the Web Accessibility in Mind project. We're a nonprofit web accessibility consultancy based at the Center for Persons with Disabilities at Utah State University. And we're passionate about web accessibility. That's what we do. You can check out our website at webaim.org and learn more about us and our services. And we have a wealth of resources and materials there that hopefully can be helpful to you on your accessibility efforts. I'm going to be presenting today on various types of stacks or layers of accessibility, just to frame a broad vision of accessibility and how these multiple pieces and layers of accessibility all come together and to result in optimal end user accessibility, and why having an understanding of these layers is important. And by breaking down these layers a little bit more, peeling them back, you can better understand accessibility and how all of this fits together. I'm going to start by really focusing on the traditional web stack. The foundational layer of that stack is HTML. We can layer onto that CSS, cascading style sheets, and then the layer on top of that is scripting or behavior. It's useful generally for development to try to keep these layers distinct, at least to think about them separately and to understand how these layers interact with each other. Our foundational layer is HTML, our structure, our semantics. Most accessibility happens at that layer. It's where we define headings, regions or landmarks, alternative text, links, lists, buttons, form inputs, labels, tables, and so on and so forth. Those foundational elements of the web are defined primarily in HTML. I often tell people that if they want to differentiate themselves from other full stack developers, to master HTML. It's kind of interesting to make that statement. We have so many wonderful, talented developers out there that have incredible knowledge of scripting, but sometimes not a broad understanding and familiarity with that foundational layer of the web stack, and that being HTML. It's a great way to differentiate yourself, is to really have that understanding of HTML, and then the other layers on top of that, primarily because accessibility, most of it happens in that HTML layer. And I think that lack of familiarity with HTML is not because it's difficult. It just really is that lack of familiarity, a lack of maybe interest or engagement. But I think it's really important for a full stack developer to understand that foundational layer. We can build on standard HTML with ARIA. ARIA can sometimes seem a little overwhelming and confusing. The way I tend to define it is that ARIA expands the vocabulary of HTML. If we think of HTML as a language, which it is, hypertext markup language, it has a defined vocabulary. ARIA, accessible rich internet applications, allows us to expand that vocabulary by adding additional attributes and values to allow it to do things that we cannot do with just standard HTML. It's important to note some caveats. This is not going to be an ARIA session, but just a few really important things that are relevant, especially in the interplay between HTML and ARIA. That ARIA roles will override the HTML native roles. Having something like input type equals checkbox, role equals radio is going to be problematic. The element will be presented as a checkbox to the user within the browser visually and functionally, but to a screen reader would be identified as a radio button. The interactions for checkboxes and radio buttons are very different. So that would be very problematic. Also, overriding a native role of something like a list that contains navigational items by giving it role of navigation. Role of navigation is wonderful, helps identify that navigation region or landmark within the page. But by adding role of navigation to a list, an unordered list, for instance, those list semantics are lost. They're overridden, and now you would have essentially list items that are not part of a list, which thus makes them not list items. And so some of those native semantics are lost. We need to be careful about how we're assigning the ARIA. We also need to understand ARIA roles and what they mean. Some of the role names are not always intuitive or straightforward. For instance, role equals menu. Many people think that that is for a navigation menu, a list of links on a web page, and that's not correct. An ARIA menu is an application menu. Think, file, edit, things like that. They have a specific keyboard interaction, generally using the arrow keys. Role of tab panel, same thing, is not for a list of links within tabs that look like tabs. They're for dynamic generated application tabs. Role of grid is not for a grid of data. It's for an interactive like an Excel spreadsheet type thing that you might build into a website. So we need to be cautious with the use of ARIA, because very, very easily we can change the semantics of HTML and introduce accessibility issues. If we want to know how to do ARIA correctly, follow the ARIA authoring practices. Use ARIA 1.1. It's the most current version of the ARIA specification. They have an authoring practices document that's really informative. It prescribes design patterns and code examples that can be used to ensure that what you're building with ARIA is correct. It also outlines proper keyboard interactions. It's vital that you implement those keyboard interactions exactly and completely. Not only will that allow the widget that you're building to be intuitive to a user as they interact with it with the keyboard, but it also aligns that keyboard behavior with the instructions that a screen reader might provide to a user. Really important that those keyboard interactions be complete, even if they seemingly don't align with the interaction that you might think your widget needs. Another important point with ARIA is that it does not change browser functionality. All that it changes is what is presented to a screen reader. And that can change things within the screen reader, certainly, but it does not change the standard browser functionality for anybody that's not using assistive technology. So screen reader testing becomes necessary. If you want to ensure that it's working right, you're going to need to do some testing. It's very important. But all of this really happens under the hood of our page in that HTML layer. We can add on to that CSS for style and presentation. Most of the visual accessibility magic happens here. We sometimes overlook this. We maybe underestimate the importance and significance of visual design and visual accessibility. We focus a lot on the code, and for good reason. It certainly has an impact, but good design, typography, white space, good contrast, use of visuals are so important to usability and accessibility. But they do and can have an interaction with assistive technologies such as screen readers. Screen readers usually ignore CSS. If it's for styling, generally a screen reader user, at least one that does not have vision, interestingly, most screen reader users do have some vision, they don't usually care what the page looks like. Screen readers usually ignore CSS. There are, however, some exceptions. A couple of those are display none and visibility hidden. Those will hide content even from screen reader users, which is wonderful. It's a great technique to use if you have content that you want to hide from all of your users. Screen readers can also read content that's generated with CSS generated content, the after and before pseudo selector. Now, the term CSS generated content should or might make you squirm a little bit, and maybe it should, because of that concept of keeping these layers separate. The idea that we're identifying content in CSS that is rendered within the page sometimes tends to blur the lines between the boundaries of these two layers. That's okay. The reality is these things are being used. We just need to understand how CSS generated content can impact accessibility. There may be cases where you want to hide content visually, but still have it read by a screen reader. The use cases for that are not very many. We need to be very judicious and cautious in our use of that. We can become overly verbose in what is being presented to a screen reader, and thus create an experience that is not the same for screen reader users that visual users get. But we can hide content off screen. Because it's part of the page, it still would be read by a screen reader. We can use CSS clip and clip path to kind of clip down the dimensions of an element so that it doesn't take any space in the page. It's still part of the page, could be read by a screen reader even though it doesn't appear visually. So those are techniques that can be used in CSS that can impact accessibility for good or bad, but very often there are some neat techniques that can be very optimal for accessibility. This layer also tends to be a little bit of a pain point, sometimes because authors don't know how best to style elements, or because they're limited by the browsers or the CSS specification in the ways in which they can style certain elements, such as form controls. Somebody today in a training I did pointed out the limitations of adding, for instance, an image within a select menu option. So just a limitation of styling of that particular element. The reality then is that people then tend to toss out CSS and HTML and go to the scripted controls instead. We need more flexibility in CSS for styling, so we can focus on HTML and CSS as those two foundational layers of kind of our web stack. It's also important that we understand the C in cascading style sheets. These are cascading, that we have a foundational layer of the browser default styles. The user can then define styles that will override or manipulate those browser defaults. The author can then define styles within the page, within external style sheets, inline styles. The author can then override those styles with their own custom styles. They're important styles, which kind of take precedence over everything else. And at the very top of this stack is the user. So we really have the user introduced in this cascade of styles in two places, just above the browser itself, overriding the browser defaults, and then at the very top of the stack, very top layer, that the user has ultimate control. So a little caution is necessary there. We need to understand that we don't have full absolute control over what the user sees. We need to give up that notion. We need to stop thinking that we can design an end user experience. We don't design experiences. Instead, we need to think and know that we have the ability to enable a positive end user experience. And when we approach accessibility and design and development that way, instead of dictating the user experience, we're going to create an environment that enables the user, regardless of the way in which they may have customized or may experience content, to have that positive end user experience. That's really powerful. It's very empowering, I believe, to accessibility. So there are some things, especially in WCAG 2.1, that are cognizant of the fact that the user can control what their end user content looks like. They can override colors. They can do all sorts of things within the page to override what you have defined as being that design. One of the new success criterion within WCAG is for text spacing. Basically, what it says that is if the user, the end user, overrides the paragraph line height or line spacing, word spacing, letter spacing styles within the page, which can be helpful for some users, especially those with maybe reading difficulties or cognitive disabilities where reading can be difficult. They can increase the spacing between paragraphs, lines, words, and letters to make reading better. That if they override those things, that it's still readable. The page doesn't fall apart, it doesn't break. That's a new requirement in WCAG 2.1. We also need to consider that users can override default text sizes. We just a couple days ago concluded a survey of users with low vision at WebAIM. This is very, very early data, but I looked really quickly at it, and over 8% of respondents had default font sizes that were larger than the default. So they've overridden that. So things can easily break if the user is increasing their text size, primarily if an author has used pixel heights to define the size of elements that contain text. As the text within those pixel-sized elements increases, the text can bleed out and overlap or flow underneath other elements within the page and thus become unreadable. So we need to be careful with that, be cautious. We can use min height, for instance, instead to define a minimum height for our default design, but allow those text elements to expand to accommodate their contents. Because the user has control over the content of our page and may view the page in a lot of different ways, we need to embrace the power of responsive design for accessibility. And do a Google search for responsive design. You did Ethan Marcotte's it's kind of a famous image. I've seen this a lot of different places of his website being viewed in responsive design on different types of displays, a large cinema display all the way down to a mobile phone. And that's a real power of responsive design, that one web page can adapt to those different environments. When you consider users with low vision, as somebody with low vision zooms or enlarges the page content, it will also trigger those breakpoints. Magnifying the content is really no different than decreasing the viewport size. You're seeing less of the page within the relative viewport that you're looking at. So one of the real powers of responsive design isn't the same web page adapted for different displays. It's that the web page may be viewed the same way for users with low vision on different devices, okay? So I may actually be seeing, because I zoom or magnify the page, I might be seeing, for instance, a phone display on a max 30-inch cinema display. That is amazing for users with low vision. As they enlarge the page, they can view it in the way that's most adaptable for them. We need to be aware of that. Somebody might be viewing your responsive phone presentation on something that's not a phone. So responsive does not always mean phone or mobile or tablet or whatever. And those things also don't mean touch. Many mobile users may be using a keyboard, especially those that will be using a screen reader or may have motor disabilities, maybe engaging with a mobile device using a keyboard. Or if I magnify the page and I see your phone responsive version on my desktop computer, I may also be interacting with that page with the keyboard. So we need to adapt to those things. WCAG 2.1 also has some consideration here. Essentially, it requires a pretty notable amount of page zoom, and that you don't lose any content or functionality, or introduce horizontal scrolling at a width of 320 pixels. Essentially, what this does is requires responsive design for most websites. You can test this by setting your browser window width to 1280 pixels. You can check that by opening the developer tools. If you then resize your browser, it will show you the browser window dimensions in the top right corner. Size it to 1280 pixels and then hit Command or Control Plus to zoom the page to 400%. It's pretty large. And ensure that there's no loss of content or functionality. Essentially, if you support usability on a small screen, say phone display, typically you're also going to support this new WCAG 2.1 requirement. There are some exceptions for things that require horizontal scrolling, data tables, big images, toolbars, things like that. This is wonderful though. Really, really supports the needs of users with low vision. Moving on to our top layer in this web stack is our scripting, our behavior, taking things and making them smarter. introducing client-side form validation, error messaging, dynamic autocomplete, AJAX calls that dynamically populate important information within the page. Wonderful for accessibility, wonderful for usability if we do these correctly. We need to make sure we don't break keyboard accessibility. Very often that's a problem with these types of dynamic content or dynamically generated things within the page, particularly single page applications. We may need to use scripting to enhance accessibility to allow programmatic focus to follow the visual focus. When a dialog box opens, set focus to it. When it goes away and is dismissed, set focus back to something else logical in the page. Error messages, menus, things like that. The accessibility of them can be significantly enhanced with scripting if we do it correctly. So we want to try to keep these three layers of this web stack usually somewhat distinct. Now, there's a bunch of code on here. If you don't understand all of this, don't worry too much about it. But it's a great illustration of this principle that supports good accessibility and good separation of these for better design, more optimal code. So at the bottom stack, we have our button here, and this is a filter button. If you press the button, it becomes essentially activated to activate the filters. Press it again, it becomes deactivated or unpressed. It's a basic HTML button with ARIA pressed equals false in its default state. On the next layer of CSS, we define very basic styles for that button when it has an ARIA pressed attribute of false or an ARIA pressed value of true. We just change the border color. Give it a blue border to indicate that it's pressed or active, gray to indicate that it's not pressed or depressed and not active. And then some basic jQuery here that simply says when the user presses the button, determine what the ARIA pressed attribute is, and then toggle it. If it's true, set it to false. If it's false, set it to true. So really what we have here is we have our basic HTML, we have CSS that handles our visual design, and scripting that handles our behavior. And very often in our scripting, we spend a lot of time dealing with visual design, right? We add CSS classes, we define CSS styles for elements to change their visual appearance based on the user interaction. That's what CSS is best at. It's really good. We can do that in, in this case, 2 lines of CSS to change those visual designs. All we do in our scripting is change the ARIA pressed attribute and let CSS do what it does best. So that's a great concept to think about in design. It's just trying to keep those layers isolated. It's not just an accessibility strategy. This is great for optimal code, for streamlining. Bruce and just got done talking about the needs for bandwidth. This is a great strategy for development in general. Many of the accessibility issues that we see arise from the complexities of taking these 3 layers of the web stack and trying to mush them all together, generally into that scripting layer, where we try to do everything using scripting alone and then write that content back using CSS defined directly for elements and manipulating HTML directly. So that's our web stack. I want to move on to what I call the accessibility stack. This accessibility stack starts with our web page. So the 3 layers I talked about before, HTML, CSS, and scripting, those are all combined to generate the web page that is loaded into a browser. The web browser is going to interpret that web page and present it visually, and also present that content to assistive technology, screen readers, screen magnifiers, voice control software, things like that. So this is our accessibility stack. Before I get into too much more detail here, I want to define a couple terms that are in the Web Content Accessibility Guidelines. Those are label and name. So in the guidelines, it requires that we provide an accessible name. Tell the user what this thing is for, that it's the register button, it's the username text box. That's the name, that's the thing that's presented to assistive technology, sometimes called an accessible name. The label is what shows up visually. So for sighted users, that's what identifies what a particular thing is. WCAG requires that we have both, that it has a name and it has a label. Typically, the name and the label are the same. So for instance, a text box with a adjacent text of first name, we can use the label element to associate that text to the control. The label and the name are the same. Now here's where you have to be cautious. The visible text of first name is the WCAG label. Don't confuse that with the label element, the label code. That's not what generates the visible label. Now, in this case, the label element contains the text of first name, the label text of first name, and that text thus becomes the accessible name, the thing that's read by the screen reader. So our visual label, and which is not the label element, and our accessible name, the text that happens to be inside the HTML label, are the same. A little confusing, but it's important to understand how those two terms are used in the guidelines. We can have name and label that are different. For instance, a link that contains an image that presents the text of next. The visual label is next, but the alternative text for that image is continue. We now have a mismatch. Visual label is next, the accessible name read by a screen reader is continue. In WCAG 2.1, it was identified that this can be an issue, it can be problematic. So there's a new success criterion that says for user interface components with labels, meaning the visual text, that include text or images of text, the name, meaning the thing that's read by a screen reader or presented to assistive technology, contains the text that is visually presented. In other words, the visible text should be part of what's read by a screen reader. This is really helpful. It helps for screen reader users. It's also very helpful for voice control users. So if they voice a command based on something they see within the page, there's underlying code, an accessible name, that ties to that so that it will be triggered correctly. So the browser goes through all of this logic and accessible name calculation for elements to determine what it should present to the screen reader so the screen reader user knows what a particular thing is. Here's a search text box. It has an adjacent label element of search, has an ARIA label of search terms, has placeholder text of search WebAIM, has a title attribute of terms are case sensitive. What does a browser, what does a screen reader do with all of these things that are all associated and identified for this particular text box? There are rules. There's logic that defines how these things should be calculated and what the browser should present to the screen reader in this case. Now, in this case, the accessible name is search terms. That's what would be read by a screen reader. Now, and you can test this in a screen reader. You can also use tools to inspect those things within the browser to see what's happening. Now, why is search terms the accessible name here? Why is that what would be read by a screen reader? Because ARIA wins most of the time. Most of the time when you have ARIA defined, it's going to override what is defined in our HTML. In this case, the ARIA label overrides the HTML label, the title attribute, the placeholder, even an ARIA description. That ARIA label is what's going to be read in this case. So a lot of this comes together, our scripting, our CSS, our HTML, including ARIA to generate this web page. And when the browser interprets that, it generates an accessibility tree. So the accessibility tree, you might think of it as like kind of a virtual version of your web page that defines all of the accessibility properties that lives within the browser. It's primarily based on the DOM. So the DOM is kind of the same thing. It's a virtual version of the page within the browser. We can manipulate that DOM with scripting, with user interactions. As that DOM changes, the accessibility tree can also change. We can view that accessibility tree using tools in the browser. We can go to developer tools, we can go to an accessibility page in Chrome, and we can actually inspect and view that accessibility tree to see what the browser has generated for accessibility from all of the other stuff that's we put together to build our web page. So that's really, that accessibility tree is really how the browser interprets your web page. So if we have a subscribe button with just a standard button element, the browser will interpret that and define a role of button. That's what this thing is. The name is subscribe, the text within the button. That's the accessible name that would be presented to assistive technology. Because we have a default role for this button, we don't want to duplicate that. We don't want to give the button role equals button using ARIA, because we don't need to. It already has that default role of button. Another example may be a link. So here's just a standard link with text within the link of register now. The role for this element is link. So the browser knows it's a link, would convey to the screen reader that it's a link. The name or accessible name is the link text. Register now. What if we were to give this link an ARIA label of, say, opens in a new window? You want to inform the user that this register link opens in a new window. Because ARIA wins, because we've added this ARIA label, it will override that accessible name. So the text of register now is no longer accessible at all to assistive technology. It's removed from the accessibility tree. The user would only hear opens in a new window for this link. Well, what opens in a new window? That content is lost. This would also be a label in name failure under WCAG. The visible text is not the same as the name that's presented via the browser to assistive technology. And again, this occurs because you told it to. ARIA wins. ARIA overrides those native semantics most of the time. So again, these are some of the dangers of misuse of ARIA. I want to take just a moment here and talk about something that's really exciting. I think the prospects are really significant for the accessibility object model. This is something that's really kind of early in design development. It's being floated around, as I understand, to browsers. It's something I think that could be really interesting. The idea behind the accessibility object model is that it would give us ability to manipulate accessibility properties directly within the accessibility tree, as opposed to in the DOM itself. So typically, for instance, if we wanted to change the ARIA pressed state for a button, we'd do that with button.set attribute, something in our scripting that would change that attribute in the DOM. The DOM is then interpreted into the accessibility tree, and it becomes accessible to a screen reader user. The button is pressed. The accessibility object model allows us to essentially bypass the DOM and make those changes directly in the accessibility tree. So most of our scripted changes happen in scripting, impact the web page, which is interpreted by the browser to generate the DOM and then the accessibility tree. With the accessibility object model, those changes are made really right at the accessibility tree layer or level. Why would we want to do this? It can be helpful for things like web components, especially web components with a shadow DOM, a DOM that's isolated from the DOM of our web page itself. That can get really tricky to try to manipulate those type of elements using our standard web page DOM when we're trying to keep the DOM of that element, that web component, entirely separate. This could also be helpful for accessibility inspection. For instance, is a particular ARIA role or ARIA attribute valid on a particular element? Is it supported? Did it take, right? When the browser interpreted our web page and generated the accessibility tree, is it complete? That could be really handy for accessibility testing. It allows direct manipulation of the accessibility tree, absent of the scripting ourselves, for the web page. It's kind of exciting, something to keep your eye on in the coming years. A lot of power here, also a lot of responsibility. The things could become broken really quickly, but it's another interesting aspect of this accessibility stack. Okay, now accessibility APIs. This is what happens between the browser and the assistive technology, the communication from the browser to the screen reader or other type of assistive technology that the end user is using. Every operating system has its own APIs. Sometimes multiple. In the case of Windows, there's multiple APIs. We don't need to get too involved in the specific details of the API itself and exactly how it works and what those channels and values are, but it's important to know that it's there. Primarily, that the browser is simply communicating to the assistive technology via these API channels to define the role, what it is, the name, how you identify it, descriptions, other properties, checkbox states, if the field is required, if it's invalid, those types of things are all defined and communicated from the browser to assistive technology. And those are determined from the accessibility tree. So you can use tools to do that. Inspect the accessibility tree. You can even inspect the accessibility APIs to see what is being communicated from the browser to the assistive technology. It's important to note that typically when we encounter accessibility compatibility issues, it's easy to blame the screen reader, because in the screen reader, that's where we encounter those issues. But usually it's the browser's fault. The screen reader simply reads what the browser presents to it via APIs. So sometimes we file bugs against JAWS or NVDA because things are not working in the screen reader, when very often it's the browser that's not communicating the correct information to it. It's important to understand that, especially if we're doing accessibility testing, so we can identify where the fault lies. Okay, so those are our layers. Hopefully it's not overly complex to understand when we piece these together. It really is not all that complex, but I think understanding those layers is vital to really building and testing optimal accessibility. In the old days of accessibility, I've been around and doing this for a long time, we didn't have to worry about most of this. We just put our accessibility in the HTML and tried not to screw it up with CSS or JavaScript. And we started to do more scripting, and accessibility supported that. But as things have gotten more complex, especially with frameworks and libraries where so much is happening at the scripting layer, where things are manipulating content within the browser, as those accessibility APIs have become so much more robust, it's important that we understand this. My friend Leonie, thank you for the introduction today. She calls these accessibility mechanics, and I love that. It's the mechanics of accessibility that all have to come together for things to work. But there's one important, critical last layer. It's a layer that fits on top of everything else, and that's the user. It's so easy to lose sight of that end user. Whether they're using assistive technology or not, what happens at those lower layers impacts the user. And we can have a role where whatever our role is in accessibility, whether it's design, whether it's coding, scripting, whether it's building browsers, whether it's building assistive technology, we have a role to play in ensuring that these layers all work together for the benefit of the end user. Okay, one last thought. Totally different change of track here, and this is a different kind of layers. These are what we call our hierarchy for motivating accessibility change. These are not technical things, but it's an important layer that I think if we want to take all those other layers, the technical aspects of accessibility, and we want it to work for people, this is the way you can best motivate people to actually implement accessibility in positive ways. So at the bottom layer of this hierarchy, we have guilt. That's a fail hashtag. It's somebody saying, if you cared about people with disabilities, you would do this. This is the worst motivator, but it's also the easiest. It is so easy to blame people, to guilt them into accessibility, but it generally does not motivate, at least not in a very positive way. The next layer up is punishment. Things like, you need to get accessible or you're going to get sued. Those types of things. Punishment can be a motivator, but again, it's not very beneficial, not very positive. It can lead to animosity, guilt, and punishment, where we view people with disabilities as the enemy as opposed to the benefactor of accessibility. Next in this stack, next higher in our hierarchy is require. This is where guidelines come in, laws. They're useful. Certainly they have motivated accessibility. They've caused a lot of change, but it's a fairly low bar. Sometimes it results in people implementing accessibility only to that level of requirement, and then they're done. It also lends itself to an approach of only technical accessibility versus functional accessibility, building something that works to technical guidelines and standards as opposed to working for users. Is that better than no accessibility? Absolutely, but we can do better. Our next layer is rewards. So that's gamification, certifications, recognition, revenue, right? Increasing our user base so we get more money. Those are all good things. They're going to motivate accessibility. But sometimes only as long as those rewards are tangible, as long as we can see them. Next is enlighten. That's doing accessibility because it's the right thing, because it's the smart thing to do. It's understanding that there are benefits for accessibility that extend just beyond people with disabilities. It's doing accessibility because anything else just doesn't make sense, right? We do it because we know it's what we need to do and should be doing. And the highest layer is inspiration. This is understanding the accessibility impacts people, and inaccessibility impacts people. And in really significant ways, it's understanding the power of the web, not only generally, but especially for people with disabilities, understanding that the web is the reality for many people with disabilities. It's their way to engage in commerce and education and learning and all of the communications. All these things that are wonderful for us are sometimes the only way that people with disabilities can engage in these types of things. So it's not just making things accessible, it's making a difference. And that is really true motivation. We want to try to move up in these layers, this hierarchy of accessibility, so we're motivating true change for actual users. And with that, I will say thank you and see if there are any questions.
Thank you so much, Jared. That was a wonderful talk. And I think those last three layers, the rewards, enlightenment, and inspiration, those are ideas for our whole community to live by. Thank you. Scott, did we get any questions coming in?
Yeah, thank you again, Jared. We do have a few questions for you. The first one, you mentioned that we should be careful on when to visually hide contents. We were hoping that you could outline some instances of when it might be appropriate to do so.
Okay, when it would be appropriate. Good, I can think of lots of examples where it's not appropriate, where things can be overly verbose and create an inequivalent experience. But where it can be appropriate generally is when there's something that visually makes sense, typically based on some sort of visual design or presentation, where a little brief cue or indicator can be useful for somebody using assistive technology. One quick example of a case that we use on the WebAIM site is for our breadcrumbs. We have breadcrumbs at the top of our articles, home greater than, articles greater than, alternative text. And visually, when we see breadcrumbs, we see it as a whole. There's a visual convention that's used there. And visually, when we quickly scan that, we generally know breadcrumbs. For somebody using a screen reader that can't see that or may not understand that visual convention, we provide a little brief text of "you are here," off screen just before the breadcrumbs. Provides a nice little advanced organizer for a screen reader user to indicate, okay, this is where I'm at. Then as they start reading the breadcrumb content, it provides that context for them. So that's the type of thing, usually small bits of information, never anything that's functional or interactive should be hidden off screen. That's one example.
Great, thank you. As a follow-up question to that, you kind of answered it a little bit with your answer right there, though. But what would you consider to potentially be better, using ARIA or CSS to create screen reader-only content?
That's a good question. Functionally, they very often are going to work the same when it comes to the screen reader. We usually recommend considering a CSS approach instead, such as off-screen text as opposed to, say, an ARIA label. One reason for that is that it provides a nice fallback. If you're relying on visual design to present something and you want to present that information to a screen reader user, if you do that via ARIA, if say CSS doesn't load and that visual design is lost, there's no fallback. You don't see that. If you do it with CSS, if CSS for some reason doesn't load or isn't applied, you then would see that off-screen text. It provides that information devoid of the visual design. So that's one motivation for that. The other would maybe be that CSS can just introduce breakpoints, potential for things to become broken if you aren't aware of it. If you use the wrong attribute, put the wrong values in the ARIA playable, for instance, things can quickly become broken. And you may not know that unless you look at your code or test in a screen reader.
Cool, thank you. The last question that we have for you is touches a bit on something that you mentioned in your talk. Increasingly, the lines between design and structure seem to be blurring again, separation of concerns and all that. Now that CSS is starting to have an impact on, and CSS is starting to have an impact on semantics, like, do you find this troubling or worrying, or like, what are your thoughts on this?
You know, it's the reality. I think we better embrace the reality. In accessibility, we spend way too much time trying to put up barriers for something that's going to happen anyways. We need to be concerned. We certainly need to educate about some of the implications of accessibility for those types of things. So yeah, it is a little concerning, especially CSS generated content, and a lot of these things that are being introduced, the accessibility processes, especially through those layers of accessibility that we talked about, haven't been defined. Should screen readers read CSS generated content or not? It's been a question for a while now. The answer is kind of, people are saying, well, yeah, I guess so. So I don't know. It's a little concerning, not because these things, they're going to happen, but we need to educate. We need to inform people that, so if they're doing these techniques, they're doing them correctly in a way that supports accessibility.
Cool. Thank you very much.
Mm-hmm.
Great. Thank
Leonie,
you for that.
Else?
Not at all. Yes. Thank you, Jared. Just a reminder for everybody who is tuned in that if you like Jared's talk, and I'm sure you absolutely did, please head over to youtube.com/inclusivedesign24 and hit that like button. And while you're there, please think about subscribing to the channel just to let us know that you're out there and tuning into ID24, which of course would not be possible without our friends and partners at Barclays Access, Microsoft Edge, Intopia, the Paciello Group, and Open Access Technologies, and with thanks to our sponsors, DQ Systems. Next up, we have Peter Grutzer, who is going to be considering HTML forms with JavaScript and ARIA. So that's coming to you on the hour. Don't go away. We'll see you then.